Ladies and gentlemen, the jury, investors, and people at Paris Space Week. My name is McMahon, and I'm the Chief Commercial Officer for Circuits Integrated HELLAS. You probably saw a great presentation from our CEO. I'm going to take you through it again, but now more at a top-level investor perspective. Who are we? Well, we've over 200 years of experience across 20 engineers, 21 if they would include me, but that's neither here nor there. We have a lot of patents in place, 5 of them. We've launched 16 products. We've worked with many different organizations, including Horizon, Agami, EDF. And we're actually profitable as well. We're generating $2 million a year with 600,000 EBITDA. So we're quite a successful company, formed in 2018. Most of our products today come from design services, but we're moving over to our product, which I'll come to later on, in regard to flat panel and SATCOM. So why SATCOM? So some of you may have seen this. This is a huge market. The estimate it's given is that there'll be over 250 million satellites in orbit by 2032. And that means that there's going to be $5 billion spent on flat panel antenna, which means that estimates are going to be somewhere between 1.5 billion to 2 billion in chips need to be provided. So we looked at this and said, this is an ideal market to go in because today, the current technology, if we look at Starlink, is quite large. It's built on legacy technology. The technology was designed like 10, maybe 12 years ago. It's called 55 nanometer, people know. And it's actually no public secret. STMicro today do most of the work for Starlink. It's complex, a lot of circuits, a lot of different, it's heavy, each one of those panels, which you see that is actually in space, probably about 2 kilos. And you've got 12 kilos are up there. So we said, right, this is a market that is really ripe for changing. So we decided to take a leaf out of what's called 3D integration. Now this has been around for a while. Intel pioneered it back in the early 2000s. TSMC do it today. ARM do it today on chips. What we're doing, which is novel, is we're doing compound semi and silicon together from a 3D integration perspective. Some of the terms you might have heard is a thing called swap-C. As a result of these changes, we change size, weight, area, power, and cost, all significantly, dramatically, by changing to 3D integration. Let's go back to that drawing I just showed you. What that would mean is that if we were to build Starlink out of CIH's product called the Kitrion, you'd remove 70% of what you see there. And at the same time, you'd actually give the additional power and requirements needed. I'm going to go quickly through. We drive down cost, 20 million per satellite launch for 100 satellites. If you think about it from a deployment perspective, you could actually add more satellites, or you can increase the scope as well. In other words, you could increase mission objectives, and you also offer a lifetime extension for the satellites which are already in orbit. Think about it, satellites are deorbiting 7 satellites a day at the moment. We have a very detailed plan for how we want to get invested. We're looking at 9 million. We've also got a very, very sophisticated roadmap. Because we're fabless, we've already worked out how to be scalable, and have worked with the partners who can actually go and bring this product to market for us as well, ultimately. Expected launch is 2027. The market itself is huge. We expect ourselves, if we actually reach where we need to be, we'll be at about 1 billion by 2032 if we had a 20% market share. We have no runway for investment because we're already fully funded. And I'll close with this. It's cost effective. It can be used across multiple markets. It's future-proof. It's scalable. And if anybody does invest in it, we're guaranteeing a 10x return on investment for 10%. Thank you very much for your time and listening.